Welcome back to the GCSE Maths Pro YouTube channel. Today we'll be going through a summary of everything you need to know for the area topic as a higher tier student. That means we'll be touching on all of these topics. Basic shapes including squares, rectangles, triangles and parallelograms, circles, semicircles, compound shapes, trapezium, sectors, and also a little bit at the end at working out the area of any triangle using trigonometry. So take a note of this first page. I've written down a very basic version of 3 formulas. Now, these ones you do need to memorize. These don't come up on your formula sheet, so you should know these. Obviously, the first one, we've got some rectangles and squares, so work out the area of these shapes. As we said, the area of a rectangle or square is the length times the width, so in this case, the rectangle, it's the 2 different sides multiplied together, isn't it? So area, in this case, is 9 times 4, which is 36. We do centimetres squared because it is now 2-dimensional. The area of a square, they've only given us one measurement, however, because it's a square, we know that all of the sides are also 7, aren't they? So in this case, it's just 7 times 7, which is 49 centimetres squared. That's literally it for rectangles and squares. Length times width. Okay, now we're looking at some triangles. Remember, it was base times height over 2, or half base times height, whichever you prefer. I'm going to write it here so you can see it as well. Base times height over 2. So in this case, this one's obviously a right-angled triangle, so the base and the height are just those there, aren't they? That's the base, that's the height. So in this case, the area is 14 times 20, and then don't forget to divide it by 2, which should give you 140 centimetres squared. This one over here, which again looks like some kind of equilateral triangle or isosceles, doesn't really matter. We can't assume what it is. It hasn't told us. However, you can see that they've told us clearly the base is 6, but you see how now we have this height. It's not necessarily a side, but it is the perpendicular height. So in this case, I can't use one of these diagonal sides. I have to always use measurements that are perpendicular. They're 90 degrees from each other. So the base is 6 times by the height is 5, and then half it again. So we get 15 centimetres squared. Okay, so now we've got some parallelograms. Again, you can see parallelograms do have these slanted sides, which we cannot use. Okay, we cannot use slanted sides. They have to always be perpendicular. So the area of the parallelogram is the base times the perpendicular height. Okay, so not necessarily a side, but in this case the dotted line. So you can see this first one is literally just 6 times 4. We're not halving it because it's not a triangle, okay? It's just literally 6 times 4. So that is 24 centimetres squared. The second one, now you can see we've got 3 pieces of information. So we have to pick out which 2 pieces of information are relevant. So we know that 12 is obviously the base. Then we have to decide, is 3 the height or is 4 the height? So just remember, it can't be a diagonal side or a slanted side. So in this case, we have to eliminate the 4. We cannot use 4 as a part of our area. Okay? So we have to do 12 times 3. The height, or more specifically, the perpendicular height in this case is 3. So we get 36 centimetres squared. So this first screen is a good one to either screenshot or make a note of. So you've got the formulas here. The first one being for the area of a circle as a whole. We've got pi r squared, which is basically pi on your calculator times by the radius r, so that's like halfway across the circle from the middle to the circumference, and then squared. So it's actually just the radius squared, not the pi, right? So it's like pi just as it is, times by, and then the radius part squared. Okay? To find a semicircle, well, that's literally just half of a whole circle, isn't it? So you're going to do pi r squared to find the whole circle, and then literally divide it by 2, or half it, to just find a semicircle. Okay, so our first question is work out the area of these circles, and I've got the formula up in the corner here for you if you haven't already noted it down. So the first one, we've got 6 as our radius. Remember, the radius is from the middle of the circle to the circumference. The circumference is basically just the circle itself, right, around the outside. So this bit here where you can see it goes halfway across the circle, that's the radius, or in this case, in the formula, r. So to find the area, I just need to do pi times by the radius, which is 6 in this case, squared. And that's exactly what I'm going to type into my calculator. So we're going to get pi, then times, and then 6 squared. I'm going to press this SD button here, I don't know if you can see, just above the delete button, which gives me 113, and if I round it to 1 decimal place, in this case, 0.1. Centimeters squared because it's area, and this is in centimeters. Now, I've got 2 more circles here, which we're going to work out the area for. The difference you should be able to see in this case is that, do you see how I've got these lines straight across the whole of the circle? So that's actually no longer the radius, is it? The radius has to be halfway across the circle. This, in fact, is the diameter. Now, the diameter is equal to double the radius, right? So 2 times the radius. Now, our formula uses the radius. So in this case, you have to double check, have they given me the radius straight away, or have they given me the diameter to try and trick me? It's a bit of a trick question. So before I work out the area, I know the diameter is 18 of this first one, 18 centimeters. So therefore I have to work out the radius. The radius is going to be half of that, isn't it? Halfway. So just remember, if you've been given the diameter, half it. So that's actually giving me 9 centimeters in this case. So I've divided it by 2. Now I can carry on and go, right, area is equal to pi times the radius squared, which the radius is 9, not 18. And then carry on as we did before. So put it in my calculator, pi times 9 squared is 81 pi, but let's say if I want it as a decimal, to 1 decimal place would be 254.5. And that is to 1 decimal place. Now we're going to move on to semicircles. It's, again, very repetitive. We're going to be working out the whole circle and then just halving it, because a semicircle is literally just half of a whole circle. So it's the same formula, you just have to remember to divide it by 2 at the end. So for this first one, you can see I've been given 2.5. That's the radius, isn't it? Because we've gone from the middle to the circumference. So I know that that is the radius. So I'm going to do, the area is pi times the radius squared, so pi times 2.5 squared. Now that's the whole circle. If you imagine if I were to carry it on like that, that's the whole circle. Obviously I only want half of that, so then I'm going to divide that answer by 2. Again, this is definitely one for the calculator. So pi times 2.5 squared, and then you can divide it by 2 then, but let me just show you. This would be the whole circle. Then I need to divide my answer by 2, because I only want half a circle. As a decimal, we've got 9.8. Again, I'm just going to round all of these to about 1 decimal place. So just remember, is it a semicircle or is it the whole circle? I need to divide by 2 if it is only semicircle. But what we really mean is, as you can see here, are shapes that have been made up of 2 or more other shapes. So in this case, you can see that clearly this is made up of 2 rectangles stuck together, isn't it? So compound shapes or composite shapes are where you've got 2 or more different shapes stuck together to create kind of an odd shape. Obviously, this doesn't really have its own name. So to work out the area of compound shapes, we're going to do exactly that. We're going to focus on the fact that it is 2 or more shapes that I can actually recognise. In this case, I know it's 2 rectangles. I'm going to choose to split up this shape back into 2 different rectangles and focus on them separately. Now it's up to you whether you want to split it across here or down vertically like that. It shouldn't really matter, it's completely your choice, whichever you prefer. Personally, I think splitting it across seems more natural. So like that, I'm going to look at it as a rectangle at the top and then this rectangle at the bottom. So to work out the rectangle, the area of a rectangle is length times width, isn't it? So let's say that this is rectangle 1 and that's rectangle 2. So rectangle 1, the area, length times width, we're going to have 12.2 times 6.5. That's quite straightforward. Obviously, this is going to be a calculator question. So 12.2 times 6.5 gives me 79.3. And that's obviously centimetres squared. Then I'm going to work out the second rectangle. This one, I mean, still length times width. However, can you see that we know, let's say this is the width at 8.9, we don't actually have the measurement for the length across. So they can actually do this with compound shapes, make it seem kind of a little bit more tricky. We're actually going to have to figure out this length here, aren't we? And they don't want you to guess, they don't want you to look at it and go, well, it kind of looks like 1/3 or whatever, for example. There should actually be an accurate answer. If you've seen our video on perimeter of shapes, you will have probably gone through this over there as well. What I'm going to do, because this is a horizontal side, isn't it? I'm going to focus on all of the horizontal sides. So this side is horizontal, this is horizontal, and then this top one is horizontal. You compare all of these. Do you see how these two horizontal sides that are below, so the one that we want to know in the 7.8, they should actually, if you were to line them up, they would be the same length as the 12.2, wouldn't they? So in that case, to find out the length of this missing one, all I need to do is 12.2 minus the 7.8, because I know that those two pieces, 7.8 plus the one that's missing, added together make 12.2. So 12.2 minus 7.8, and that gives me 4.4. Okay, so we're not going to guess, we're going to work it out accurately. So that's 4.4 there. So now I can work out the area of that second rectangle. I know that it's going to be 4.4 times 8.9. Again, put that in your calculator. 4.4 times 8.9, which gives me 39.61. And the last bit is, I've got the two areas separately. What I want to do now is add them together. Okay, because that's effectively what they've done with the rectangles, isn't it? They've just stuck them together. So the last bit is, so the total area is 79.3 plus 39.16. 79.3 plus 39.16. And I'm just going to round that to one decimal place, would be 118.5 centimeters squared, and that's to one decimal place. Okay, so this third shape here we have, it's a little bit harder to picture, but it's actually, I draw a line directly horizontally across, it's actually, again, a rectangle at the bottom, but at the top is a semicircle. So I'm going to label it 1 and 2. We'll start with the rectangle because that is the easiest bit, isn't it? So the area of a rectangle, as we've done in the last few questions, is length times width. 4.6 times 6.7 in the calculator. 4.6 times 6.7 gives me 30.82 centimeters squared. And for the second bit, so a semicircle, we know, if you've checked out the previous video, if you haven't, I'll link it here, is the area of a whole circle and then just divide that by 2. So the area of a whole circle is pi r squared, isn't it? And then in the case of a semicircle, which is obviously half, we'll divide it by 2. So we need to know r, which is the radius. Now this is the bit that we have to figure out. The radius is only halfway, isn't it? So about here across. It's exactly halfway because the centre of the circle would be exactly halfway across there. Now, because the bottom shape is a rectangle, I know that if this horizontal line at the bottom is 4.6, then this horizontal dotted line I've drawn here also has to be 4.6 because that's a rectangle. So if I know that the whole of that line, which in this case is the diameter of the circle, is 4.6, so the diameter is 4.6, and if you've seen that previous video, you'll know that the radius is half of the diameter exactly. So to find the radius, all I need to do is divide the 4.6 by 2, which should give me 2.3. Okay, so that's how you figure out the radius in this case. You just look at the other information they've given you on the question. Don't guess anything, they should give you enough information for you to find it out. So we need to do pi times 2.3 squared, and then don't forget to half that to divide that by 2. So pi times 2.3 squared over 2. Now, obviously, this one will normally give you quite a lot of decimals, so I'm not going to write down all of these. I might just write down maybe 2 decimal places, because that's what will affect my other answer when I add them. So 8.31 I'm going to write down. 31. Now, what you can do in your actual calculator is just keep the answer and add it directly, copy the answer. So the last bit is just the total area, so I need to add them together. Total area equals 30.82 plus 8.31. Now in this case, I can use my answer button to copy that answer. If you see at the bottom, you've got this button which says A and S. If you use that, it will copy all of those decimals. So we might as well do that. And then plus 30.82 equals, now this is my final answer. So now I'm going to round it to 1 decimal place, I think. 39.1 centimeters squared, and that's your answer there. This is one where it's actually more of a cutout situation. So it says here, work out the area of the shaded shape. So just the bit you can see shaded in blue. We don't actually want to know the white bit in the middle. However, I'm looking at this, it's kind of like a photo frame if you imagine it that way. What I'm going to do is work out the area of the small rectangle, which is the white one in the middle. I'm going to work out the area of the big rectangle, which if you imagine, if I were to work out the area of the big rectangle, it would be all of that, wouldn't it? It would be all of that including the white bit. So if I can work out the whole of the rectangle, and then I can work out the white rectangle, I can then just take it away. It's like a cutout, isn't it? Subtract it in this case, because there's something missing on the middle. So I'm just going to call it like the white rectangle. Let's work that one out first. So obviously rectangles are still length times width. So you can see here, the white rectangle, we've got the 20, that's fine. However, we are missing the vertical edge. So I'm going to look vertically. I know the whole rectangle, the bigger rectangle, is 35 in terms of the height here. I know that this is 4.5, and in terms of a photo frame, obviously, these would be the same, wouldn't they? So we know that this is also 4.5 down here. So the height that I want in the middle for just the white rectangle is going to be 35 minus 4.5, minus another 4.5, isn't it? So I'm going to put that in the calculator. 35 minus both the 4.5s. Gives me 26. Okay, so I've got 20 times 26, which gives me 520. So that's the white rectangle in the middle, the cutout, if you imagine it like that. Now the blue rectangle, which as I said before is going to include everything on the inside, so including the white bit, we've got 35 times 27. Now that one they have actually told us directly, so that's quite easy. 35 times 27 gives me 945. So in this case though, just be careful because we're not going to add them together now, are we? Because they're not two separate rectangles added together. It's clearly that we've got one rectangle and then we've cut out the middle bit. So we've actually lost the area of that white rectangle. So the total area of this photo frame, if you imagine it like that, is going to be 945 minus 520 minus the cutout. Because all I want is the shaded area, not the whole of the inside of that whole blue rectangle. 945 minus 520 is 425, and now that is your final answer. 420 is just the shaded area. So our first slide is obviously going to give you the formula for the area of a trapezium. I have drawn two separate trapezia here so that you can see that they do sometimes look a little bit different. Now, the actual area of a trapezium, the formula is A plus B over 2 times specifically the perpendicular height. So we're going to break that down. A plus B, first of all, you're thinking, okay, yeah, but what even is that referring to? As you can see, I've labelled it on these two diagrams here, and you can see over on the right-hand side, it says A and B are always the parallel sides. Okay, so some people say, oh yeah, A and B are the top and the bottom of the trapezium. Well, in the case of these two diagrams, yeah. However, you could have a trapezium that stood upright, and what I mean by that is it could look like this, for example. In which case, the parallel sides, do you see, are not the top and the bottom, but the left and the right sides. Okay, so just be careful, you know that A and B are more specifically the parallel sides. Whichever way they are rotated, it doesn't matter as long as they're parallel. It doesn't matter in that case which is A or B as long as the two are correct, being A and B. So like, for example, I could put that as B and this one as A. That's fine, because either way they both have to be A or B. Then you're going to times that by the perpendicular height. Now, in the case of the left-hand trapezium, that's quite obvious which is the height. It's just one of the sides. Whenever you have diagonal sides, we never use those measurements to find area. They always have to be perpendicular measurements. So even if they told you, let's say on this left-hand diagram, they told you the length of this one, that's not the height, okay? You always have to go with perpendicular, which is why I've drawn this right angle here. Now, in the case of the second trapezium, which looks slightly different, obviously neither of the two sides are the perpendicular height. They're both diagonal sides, aren't they? So we need to ignore those, and that's why you can see I've got this dotted line here, this paler line. Now that's meant to obviously go down to the bottom. But you can see I've drawn this 90 degrees box as well, this perpendicular height. It might not always be an actual side, it might just be a vertical or perpendicular measurement. Okay, so the same as you would have seen with triangles and with parallelograms. We're never using diagonal sides for the height or for any kind of area measurement, okay? In the case of this one I've drawn at the bottom, where it's obviously still a trapezium but rotated, the height in that case, let's say if that was a right angle, would be this. Now I know that's obviously a cross, isn't it? But in that case that is the height. So for this first one, work out the area of the trapezium. Okay, well first of all I need to label the sides or the measurements that are relevant to me. So first of all, A and B we said are the parallel sides. In that case, that's obviously going to be the top and the bottom here, because these are parallel sides. And then obviously here we actually have a side which is a perpendicular side, so I can use this one as the height. And then we're just going to put it into our formula. So area is 9 plus 13, so a plus b over 2, so that will find the average between the two sides, the top and the bottom, times by the height, which is 10. So then grab your calculator, I'm going to type it in here. Obviously this one I think we could work out ourselves. This question could still come up on a non-calculator paper if they use nice enough numbers. I'm just going to show it here though. I'm just going to work out the first bit, the a plus b over 2, just so you can see. 9 plus 13 over 2 is 11. Do you see how 11 is exactly the middle of 9 and 13? It's like the halfway point, isn't it? A midpoint, or effectively the average. And then you take that, so we're saying, right, the average of the horizontal sides in this particular question is 11, and I'm going to times it by 10. So actually, it just relates back to the same formula that we use for rectangles, length times width. It's just that we have to first of all work out what is the average length, because obviously you've got two different options. So if you wanted to know kind of why we do that, that's the reason. Otherwise, don't worry, you don't need to try and explain it yourselves. Either way, the answer is 110 centimeters squared for this one. Okay, so the next question, we've got a slightly different looking trapezium, although obviously it still is a trapezium all the same. So work out the area of the trapezium. So I'm going to label my sides first. So A and B are the parallel sides. So again, in this case, they are the top and the bottom, aren't they? So we've got A and B. Doesn't matter which way round those go, as long as A and B are the 7.5 and the 15.4. And then in this case, the perpendicular height is not one of these sides, is it? Because those are diagonals. It's actually going to be this dotted line here, the 9.2. And once I figure that out, I'm just going to type it into the formula again. Over 2 times by 9.2, we get 105.34. Obviously that one was more of a calculator one because of the decimals. And there we go. So as always, we're going to have here the formula of the area of a sector. Basically here we have a sector of a circle, and the way that we find the area of this is we're going to first work out the area of the whole circle, which you should know by now is pi r squared. That's just for the whole thing, isn't it? And then to find out just this smaller part of the whole circle, we're going to times that by a fraction. And the fraction is, well, how much of the whole circle do I actually want? Well, in this case, you can see we've got theta, that's representing the angle, out of 360. Now, obviously, around a point is 360 degrees. So if we know the angle of the sector, which obviously they'll give us as a number, then that is literally the fraction of the circle we want, isn't it? Like a portion of the circle that we want. Now, this won't be on your formula sheet, so make a note of this formula, but hopefully the logic is there that you can kind of think, well, yeah, makes sense. I'll just find the whole area of a circle, which I know anyway, and then times it by the fraction that I want based on the angles. So the first one, work out the area of the sector. Okay, so we've been given 2.1, which is obviously here the radius, isn't it? So to start with, I want to find the area of the whole circle, which is pi r squared, so pi times 2.1 squared. Then I'm going to times that by the fraction of the circle that I want. So actually I've been given 64 degrees. So it's 64 degrees out of the whole 360 that would have been in the whole circle. Once we've written that down, we just need to put it in the calculator. So we've got pi times 2.1 squared times 64 over 360 as a fraction. And here we are. So I'm actually going to give it to, I think, 3 significant figures, so 2.46. Let's go with that. Now, normally if there's decimals, they'll tell you how to round it, but in my case, I'm just going to choose 3 significant figures. Okay, so 2.46 centimeters squared is the area. Okay, so now that we've practiced working out the area of a sector and using the formula, we've actually got a slightly more complicated question here. As you can see, we've got a sector, and then within that sector, we've got a semicircle. And it says work out the shaded area, so just this blue bit here. But in this case, when you've got this kind of odd shaded area, which is, you can't really describe what shape that is. It's actually a cutout scenario. So in this case, what I'm actually going to do is we're going to have to work out the area of the whole sector, the area of this semicircle, and then just take them away, because the semicircle is a cutout, isn't it? So let's do area of the sector, because that's what we've been doing. So we've got pi r squared. Now the radius of the sector, do you see, is actually 1 plus 5, isn't it? It's going all the way across. So in this case, we've got the radius as 6, so just be careful you get that right. Times by the angle, which they've given us is 72, so that's fine, 72 out of 360. And straight into the calculators we did before, so times 6 squared times 72 over 360. You can write this down in terms of pi if you like, but I'm just going to have a little look. I'm going to write down a couple of decimals, so 22.619, let's write that down. Now I'm not rounding it too soon because obviously I haven't actually found the final answer yet. So that's my whole sector, but that's including the semicircle, isn't it? So I'll put it, that's a sector. Now we need to find the area of the semicircle, which if you've seen that other video, you'll know what to do, but you can also use this exact same formula here. The only thing is that obviously the angle, that's the middle, is 180, isn't it? So you can use 180 over 360 if you like. Or if you remember what we did in the other videos, you obviously do pi r squared as normal. Now the radius of this one though, because just remember, the 5 is actually the diameter, isn't it? So the radius is actually 2.5. So just be really careful with that as well. That would be the whole of that circle if you were to continue it around. But being a semicircle, it is only half, isn't it? So either you do that and divide it by 2, which we did in our previous video, or you can times it by the same formula here, but just know it's obviously 180 out of 360. Now 180 out of 360 is half, isn't it? So it's exactly the same thing. Whichever you prefer to do, whichever makes sense to you, it's the exact same answer. So here we've got pi times 2.5 squared times, let's say 180 over 360. We get 25 over 8 pi, or as a decimal, 9.817. Now I'll just go back and show you if I were to do it the other way. I would have pi times 2.5 squared over 2, that's the other way, isn't it? Do you see how I get the same exact answer, 25 over 8 pi, or 9.817? I'm just going to write down as well a couple of decimals. 817 dot dot dot. Okay, so I've got 2 areas here. Now in this case, because it's a cutout, isn't it, I'm going to subtract them. I'm not going to add them like we do with other compound shapes. So the last bit is the area of the shaded region is, we've got 22.619, which was the whole sector, minus 9.817, which was the semicircle that we need to cut out, which gives me 12.802, which I'll just round to 12.8. And that's 1 decimal place, isn't it? Okay, so that's your final answer there. So that's how they could make this topic a little bit more complicated, okay? They might throw in a shaded region that is a bit of an odd shape, and you have to work out multiple things to then subtract them at the end. Either way, we still ended up using the same formula. So I've got this here as the sine and cosine rules, but it does relate as well to using this formula, this trigonometric formula for the area of a triangle. It's going to be used for triangles where A, they're not right angles, but also normally with a triangle, you would do base times height over 2, or you might have seen it as half base times height. Yeah, that is still area of a triangle for sure. However, that relies on the height, and that's not just any height. That is normally the perpendicular height, which in this case would look something a little bit like that. Okay, that would be the height, and then this would be the base. So if you're not given this height, because that's not actually a side length, is it? If you're not given the height, if you only have the diagonal sides, this is when we're going to be using the formula that we have here. So the formula is half AB sine C. You've got your angles as the uppercase letters, A, B, and C normally, and then the sides as lowercase. The angles are always opposite the same side. So for example here, angle A is opposite side A, angle C is opposite side C, and angle B is opposite side B. Okay, so that has to work like that. In this case, we've got the formula based around AB sine C. So it's basically this angle and then the 2 sides that surround it. You might need to scribble out and change the labels if they've got A here, you might want to change it just so you know that you've got letters in the same place and not have to change the formula, that's fine. But effectively we're looking for 2 sides and the angle between it. That's how we can use this to find the area. So screenshot this if you want it for your revision. It should also be on your formula sheet so you don't have to memorise it as such, but it's just helpful to have it in your notes. So let's get straight into it. If it just says simply work out the area of triangle ABC to 1 decimal place, again you can see we can't work out base times height over 2. or half base times height, because we don't have the perpendicular height, so we have to use trigonometry. So in this case, I'm going to label sides. Luckily, angle C is in the right place. I've got angle B, and therefore this is side B, angle A, and therefore this is side A. So I've got A and B and the angle between them. So the area equals, we just sub it into our formula now, half. Now these are all just times together, so 3.8 times 4.5 times sine of the angle 72. Make sure to close all your brackets. Now you obviously will need a calculator for this one, but particularly your scientific calculator. Do not try and use your phone calculator because that will be a nightmare. So half, you can put it at 0.5 as well if you want, times 3.8 times 5.4 times sine of the angle 72, close the bracket, and there we go. We don't need to do anything, that is literally just the answer. So it said one decimal place, we've got 9.8, in this case centimetres squared. So it all just comes down to labelling the triangle correctly and having the right sides and the right angles. It has to be, and I keep saying this, but it has to be the angle and the two sides that surround it. Okay, so this side over here, not relevant. So they might try and make it a little bit more complicated. In this case, they've given us the area already. So they've said the area of triangle ABC is 23.5. So 23.5, I don't know why I like to put it in the middle, but I just do for some reason. Work out the angle BCA. So BCA is this one. Okay, luckily, angle C is the one that it's based in, and we've got the two sides surrounding it. So that's side B and that's side A. So I'm going to set up my equation, but again, now I actually have the area, don't I? So instead of writing A, as in the area A, I can write down the number 23.5. Then I have half side A, which is 10.8, times side B, which is 9.6, times by sine of angle BCA, which I don't have. So always set up your equation, put it equal to the number they've given you. Now I actually just have to do some rearranging. What I'm going to do first is probably work out these three things times together before I move anything. So I want to have sine BCA as the subject, don't I? So we'll do half times 10.8 times 9.6 first, just to find that out. Probably not going to be great. Oh, not too bad of a decimal. That's fine, so I'll write that down. So I've got 23.5 equals 51.84 times by sine BCA. So actually, when I rearrange this, it's just algebra now. I want to move this across, don't I? And because they're currently times together, that means I'm going to have to divide. So divide both sides by 51.84, or your answer button, obviously, if it's a massive decimal. So on the right side, we'll get just sine BCA left. And on the left side, I'm going to use my answer button. So 23.5 divided by answer is a really, really bad number. So maybe it's better if you don't write it down. You could write it as the fraction if you wanted to, but I guess I'd probably skip writing that down. Okay, and again, we keep saying this, anything to do with trigonometry, whether it's SOHCAHTOA, whether it's sine rule, whether it's cosine rule, whether it's this trigonometric area formula, if you're trying to find an angle, obviously at the end, you're going to have to do the inverse of either sin, cos, or tan, in this case obviously sin, because the angle is obviously not 0.4 degrees. So I now need to do sin inverse, so you press shift and then sin. Answer button, don't round it anywhere near to the middle of your working, you have to round it only at the end. So use your answer button every other time. Okay, that seems a bit more reasonable. It's now saying 26.95 degrees. I'm probably going to round it to one decimal place, so that would round to 27.0 degrees is equal to BCA. Okay, so it's the same formula. I've still labelled everything correctly. I've still subbed it all in. All I had to do was a bit of rearranging, which is nothing to do with trig. It's actually more to do with just algebra, isn't it? So make sure you're happy with rearranging, because it could happen within the context of actual shapes as well. The area of the square is twice the size of the area of the rectangle. Work out the width y of the rectangle. So we're going to have to create another equation. It's a little bit more complicated this time. So look at this, we've got the area of the square, and wherever you see in a question it says is, you can always put that as equals. Is the same thing as. And then it says here twice the size, so I'm going to say 2 times the size of the area of the rectangle. Okay, let's just pause on that for a minute. The area of the square we can actually work out immediately as a number, can't we? Because we know, I draw that as a little square, we know that all of the sides are the same, so that's also 8. So 8 times 8, which gives me 64. So, okay, so I know that this side of my equation is just a number 64. And then the area of the rectangle, I can't work it out as a number as such, but I can write it down in terms of y. So the area of a rectangle again is going to be length times width, so y times 2, or in that case 2y is how I'd write it down. Technically centimeters squared if you want to be technical about it. So that's the area of the rectangle, 2y. So you see how now at the top here in pink I've kind of built this formula. What I can write it down is 64 is, or equals to, 2 times 2y, or the area of the rectangle. Okay, so the square is twice the size of the area of the rectangle, so I need to double the area of the rectangle. So that's my equation. I'm obviously now going to actually times that by 2. So 2y times 2 is 4y. And then all I need to do is solve it to find y. So the opposite of timesing is obviously divide, so I'm going to divide both sides by 4. And then that gives me y, it's just 1y, and also on the left it gives me 16. And they've said work out the width y. Well, y is 16. 16 centimeters is the answer. So we've got a sector. We've been told the area of the sector, and we need to work backwards to find the radius. So the area of the sector is 12.1 centimeters squared, and they've told us that the angle here is 46 degrees. So with these questions, I always start out by writing down the formula and substituting in any information I already know. So we've got pi times r squared, obviously pi r squared, we don't know the radius, so I'm going to leave it as r squared, times by theta, which is the angle, isn't it? So in this case, I actually do know 46 is the angle over 360. Now on the left-hand side, that's normally where I would write area. But in this case, because we do actually know what the area is, I can write down the number 12.1. So now if you see, the only letter that's missing is r, is the radius. Obviously pi is just a number, isn't it? 3.1 ... So the only thing that's missing is the radius. So now I just need to rearrange this so I can get the r on its own. So we're almost forgetting again that this is no longer really important that it's area, it's just an equation that I need to rearrange. So my first thought is, and I guess you could do 2 different orders here, but I'm probably just going to move this whole fraction across. And you can see that they are multiplied together. So to move the fraction, I'm just going to divide. So divide by 46 over 360 on both sides, obviously because it's an equation, we need to do it to both sides. The right-hand side is then just pi r squared, isn't it? Because that whole fraction has moved. But the left-hand side, I'm actually going to have to divide. So I've got 12.1 divided by that fraction, 46 over 360. Which obviously is going to give me a horrific number. In this case, this is all recurring decimals. So what I'm actually going to do is write it as the fraction so I don't lose any decimals. Now, it's not an ideal fraction either, but it's still better than writing all the decimals. So I've got 2,178 over 23. So I'm just going to write that down so I don't have to miss any decimals. Try not to round anything or any numbers before you get to the end. We're not at the end yet. So don't round anything. If you want to write down a couple of decimals, but as long as you keep the whole answer in your calculator, so you might write down 94.695 ... As long as you use the actual whole number that is in your calculator and not just the one you've rounded, then that's fine. But I prefer in this case, because the number is quite annoying, just to write down the fraction. So now I am still trying to get r on its own, so the other thing to move is the pi, isn't it? Again, pi r squared we know is multiplied, so I need to divide by pi as well. You can divide by both of these in one straight step, that's fine, but I'm just kind of over explaining it. So obviously the right hand side is then just r squared, and my left hand side I'm going to need to divide by pi. So leave your answer here, just press directly divide and it will copy, the A and S means answer, it will copy the whole of the answer you just had, so we won't lose any decimals. Divide by pi. Okay, now I've got a number which doesn't come as a fraction, so I will just write down a couple of these decimals, but I will keep the whole number in my calculator. So let's say 30.142 roughly. And I'm going to put ... so I know that it does carry on. Now the last thing is I want to get the radius on its own. I don't want the radius squared. So the opposite, or the reverse of squaring, is square rooting, isn't it? So I now just need to square root both sides. So again on my calculator, I'm just going to directly put square root and then put the A and S button. So that copies all of my decimals. And here I've got 5.490 ... Now that's the final answer, isn't it? So here we've got, on the right hand side, just r because I've square rooted it, and on the left hand side we've got 5.49 ... So at this point I am going to round it because this is the last bit, isn't it? So I'm just going to round it to 5.5. Again, in your question, they should tell you how to round it. So the final answer here is that the radius is 5.5 centimeters, obviously to 1 decimal place in this case. And there we are. Okay, this is our last question. It's kind of similar, but now you can see we've got even more algebra coming into it. So we've also been given the area. The area of the triangle ABC is 135. This case, can you see how we have actually got the letters in the wrong place? Now, you might be fine with this one because this one's not as a complicated formula as cosine rule, but I would always advise that you change any so that it matches what they have in the formula. So what I mean by that is this formula is based in terms of angle C, isn't it? So that's angle C. Therefore, this side is C, but I don't actually need that. And I'll just swap that one for B. So therefore, I've got side B, side A. Just so that I know I've got exactly the right things I'm putting into my formula. So now I've got the area, which is actually 135, so I'll put that down, equals half. Now in this case, can you see how we've actually got sides in terms of x? So we've got 4x minus 3 and then 2x plus 5. So I need to put, for A is 2x plus 5, put the whole thing in. So we're still substituting. B is 4x minus 3, and then times by sine C, which is 150. Okay, subbed everything in. I'm going to have to rearrange and solve this equation. First thing I want to do though is I don't really want this sign. I just want to be left with x's and numbers. So let's look that up first. Hopefully it's a nice number. They might throw in surds here if they want to be really mean, but I've obviously not done it. In this case, I made it quite a nice number. It is just a half. So what I can actually do is instead, I can write that as a half. So we've got 135 equals a half at the front times by 2x plus 5 times by 4x minus 3. And then at the back, we've also got times by another half. What I'm probably going to do here is when you're timesing any numbers together, it doesn't really matter which order you times them in. I know it's written in this order, but what I can do is I can pluck out these two things, times those together first. For example, if you did 5 times 2, you get 10. If I do 2 times 5, I still get 10, right? So it doesn't matter which order you times everything in. So 1/2 times a half is a quarter. So I've actually got this. Now what I'm probably going to do is expand these brackets as well. So let's do that at the same time. So expanding the brackets, we've got 8x squared, make sure we expand these correctly as well, minus 6x plus 20x, and then minus 15. Just make sure you've got the pluses and minuses correct as well. What I'm then probably going to do is, I think I'm actually going to get rid of this quarter, and what I mean by that is, it's currently timesed, so what I actually need to do is therefore divide by a quarter on both sides. Now on the right hand side, it's not going to affect my bracket because it's just going to cancel that out, isn't it? But on the left-hand side, I'm going to have to do 135 divided by 1/4. That is the same as timesing by 4 if this is a non-calculator paper. So I've got 540. So I've got 540 equals, now these brackets are opened up. I've got 8x squared. I'm going to add these together, so that's plus 14x minus 15. Okay, it's looking a bit better now. Can you see that we are going to end up with a quadratic? Okay, the x squared is not going anywhere. So normally, obviously, when you've got a linear equation, which is just something with just x, not x squared, just x to the power of 1, you would get the x on one side and all the numbers on the other. But because I know it's going to be a quadratic, I need to have everything, all the terms on one side and a 0 on the other. Now, it's probably easy to move the 540, isn't it? So to move the 540, I need to subtract it. And then I'll get 0 on the left-hand side. It doesn't matter which side the 0 is on, as long as 1 is 0, 1 has got everything else. So we've got 8x squared plus 14x minus 555. Now, this is the thing. This is likely to be, definitely likely to be a calculator question in this case. However, if it wasn't, you would obviously normally solve quadratics by factorising. In this case, I honestly don't really fancy doing that. I'm sure you can do it. The 8x squared and 555 I just don't really want to deal with. So what I'm actually going to do is another option to solve quadratics is using the quadratic formula, which will also be on your formula sheet, so you don't need to memorise it, but I will write it down here anyway. Now, the A, B, and C in this is not to be confused with the A, B, and C of the side lengths, okay? The A, B, and C here is just purely to do with my quadratic. If you've got it in the correct order in terms of x squared, then x, then a number, then A, B, and C is in that order. So let's just get our calculator. So we've got minus B, so minus 14 plus, or minus, choose whichever one you want first. Normally I do plus first. B squared, which is 14 squared, minus 4 times A, which is 8. Now the C does include that negative, so it is negative. Okay, don't forget to put that in. Otherwise, you will get a math error. 2 times A, which is 2 times 8. There we go. So one of my solutions is x is 7.5. So x equals 7.5, or now quadratics, you always get two answers, don't you? Remember when you factorise, you get two brackets. So I have to go back, don't delete it, just use your back arrow, and just change this initial plus to a minus, or vice versa. The other option is minus 9.25. Now, in this case, because we actually have an actual context, you're going to have to choose, because it says work out the value of x. It doesn't say values, it doesn't say multiple, it doesn't say what are the possible values, it says what is x, okay? So in this case, I need to choose based on the context. Now, if we come back here, we're talking about side length. That's the context, isn't it? You can't have a negative side length or a zero side length. So in this case, if you've got, let's say, 2x plus 5, obviously the positive one is still going to be positive in both scenarios. The negative one, if I do, just to show you for a demonstration, if I do 2x plus 5 in that case, so that's 2 times minus 9.25 plus 5, that's still negative. I can't have a negative side length, can I? So that tells me, normally this is the case when you've got a shape and you're trying to find out x. Normally you choose the positive one. If there are two that are positive, just test them both out and one of them will end up being negative in terms of side length, you choose the other one. So in this case, the answer is x is 7.5 centimeters. Okay, so you have to choose. So thanks for watching this video. If you would like to go through any of these topics in more detail, the full videos will be linked down below. Make sure to like and subscribe and leave down below any questions or comments that you might have.